Hi everyone, welcome to EdXP. EdXP is a learning and assessment platform for students to practice and test themselves outside of the classroom. Today I'll be covering the topic of probability, which is a topic covered in both standard and higher level AA subject for IBDP Mathematics. So let's jump right in. I'll cover a total of 5 questions today. The first 3 are from past papers and the last 2 are from our EdXP database. So let's jump right in. The first question over here came from our May 2016 Time Zone 1 Paper 1, question 4 in the HL examinations. Okay, for 5 marks, on the Venn diagram, shade the region A prime intersect B prime. Okay, so A prime intersect B prime is actually on the outside, not touching the insides. Okay, so we can shade the regions over here. Okay, always remember that intersect is end. Okay, and the overlap of A prime and B prime. So try to figure it out on your own. Yeah, A prime intersecting B prime. Where do A prime and B prime, where do they overlap? That's what we want. Okay, so for 1 mark that is done. 2 events A and B are such that the probability of A intersect B prime is 0.2. Okay, so A, where does A and B prime overlap? Is over here, 0.2. Okay, and the probability of A union B, everything in the circles, is 0.9, which means that the outside is 0.1. It must be, okay, because total probability adds up to 1. We want to find the probability of A prime given B prime. Okay, so this is given conditional probability. We can use the formula in our formula sheet, so that will be the probability of A prime intersect B prime over the probability of B prime. And we know that the numerator is 0.1 and the denominator B prime, so not B, will have to be 0.3. Simplifying answer is 1/3. Okay, I'll move on to our second example. In this second question, this came out in the May 2016 Time Zone 2 Paper 1 question 5 in the HL exam. For 8 marks, a biased coin is tossed 5 times. Whenever I see a question like this, immediately I know there's a fixed number of trials n, so I'm actually thinking of the binomial distribution. Okay, so that's how you must think. The probability of obtaining a heads in any of the throws is P. Yeah? Let X be the number of heads obtained. Okay. Part A, find in terms of P an expression the probability of X equals to 4. Okay, we must identify this to be a binomial distribution. Why? There are 4 assumptions. The first one is if all 4 criteria are met, it is a binomial distribution. The first one is a fixed number of trials, which is 5. Okay. Number 2, the probability is constant, which is P. Number 3, they are independent events. Independent events because all the coin tosses do not affect one another. And number 4, 2 outcomes only, either a heads or a tails. Okay. Since these 4 criteria are met, it is a binomial distribution. So we can say that X follows a binomial distribution of 5, P. Okay, that's defining our distribution and our variable. The probability of X equals to 4. Okay, so for those who want to better understand binomial distribution, I toss the coin 5 times, 1, 2, 3, 4, 5. And I want to have 4 heads, so I can place them anywhere. 1, 2, 3, 4, for example. Okay. So there are 5 slots. I want to choose 4 slots to be heads. Okay, and since there are 4 heads, I have to do a P power 4. And since there is 1 tails, it's 1 minus P. Okay, so that would be the answer for part A. Part B. Determine the value of P for which Px equals 4 is a maximum. When I see maximum, I think of 2 things. Either I do the quadratic method Okay, so I have a sad face, or I do differentiation. Since I don't have a quadratic equation here, I might want to do differentiation. Okay, so I want to expand this. 5 choose 4. Okay, there'll be 5 ways to do that. So it's 5 times p power 4 times 1 minus p. Okay, maybe I'll do a quick expansion. So it's 5p4 minus 5p5. Okay, let's differentiate this. Let's call this x, for example. Okay, so dx by dp will be 20p cubed minus 25p4. And I equate it to 0 to find a stationary point. I can factorize my expression. I can take out p cubed. I can also take out maybe 5. So I'm left with 4 minus 5p equals to 0. Okay, so we either have p equals to 0 or p equals to 4/5. And p obviously cannot be 0. The probability can't be 0. So we reject this. So the answer is 4/5. And B, part 2. Determine the expected number of hits. The expectation or the average for a binomial distribution is given by ex equals to np. Okay, so this is also in your formula sheet. So the expectation will be 5 times 4/5. So the answer is 4. Okay, I hope you got that. I'll move on to my third example from past papers. This question came out very recently in the May 2021 November paper, paper 1, question 4 in the HL examinations. So let's go right in. Question 4, for 5 marks, we have box 1, which contains 5 red and 2 white balls, so total 7 balls. Box 2 contains 4 red and 3 white balls, so that's 7 balls as well. Okay, part A, a box is chosen at random and a ball is drawn. Find the probability that the ball is red. When I see such questions, immediately I want to use the tree diagram. Hopefully this will help me. Okay, so if I choose a box at random, it's either going to be box 1 or box 2, and the probability is half for each. Okay, random. The probability of drawing a red and white for box 1. For red, we have 5/7, which means that white must be 2/7. Okay. The probability of drawing a red in box 2 is 4/7. And for a white in box 2, that will be 3/7. Okay, and there we have a simple tree diagram for paper 1. Find the probability that the ball is red. The probability that the ball is red. Okay, we have to actually add these 2 branches, 1, 2. Okay, so using the addition and multiplication principle, it's half times 5/7 plus half times 4/7. So that will be 9/14. That is the answer for part A. Okay. Part B. Let A be the event that that box 1 is chosen. Okay. And R be the event that a red ball is drawn. Determine whether events A and B are independent. Okay. For 2 events to be independent events, i.e., okay, the probability of A given R must equal to the probability of A. This is the criteria. So R does not affect A in any way. Okay. And if we use the general formula, okay, that on the left-hand side, the probability of A given R is actually equal to the probability of A intersect R over the probability of R. Okay, if they're independent, this must be true. This must be true. Okay, so on the left-hand side, let's do one by one to see if it's true. On the left-hand side, the probability of A intersect R. So box 1 and R will be half times 5/7 divided by the probability of R. A red ball is drawn. We found it in part A. That is 9/14. Okay, so that'll be 5/9 on the left-hand side. And the right-hand side over here, the probability of A. is actually, what is the probability of box 1 being chosen is half. Okay, so this is important since they are not equal. Okay, 5/9 is not equal to half, therefore not independent events. Both A and R are independent. Okay, so I've covered 3 examples from past papers. I'll move on to some of our questions from our EdXP database. Feel free to try them online at edxp.com. Okay, so this is a probability question at level 1. Okay, so let's jump right in. Brandon is 75% sure that he left his bag either at subway or in school. He's 35% sure that the bag is at the subway and 40% sure that it is in school. Okay, when I look at this, I immediately think of the tree diagram. Okay, so let me draw it. So we're going to try to use a tree diagram to visualize this. So Brandon, he's 75% sure that he left his bag either at the subway or school. Okay, and out of which he is 35% sure that it's at the subway, 40% sure that it's in school, which means that 25% of him thinks that it is somewhere else, yeah? Fair? I think that's fair. Okay, given that, when we see given that in the exam, we know that this is a conditional probability type of question. Okay, so given that Brandon already went to school and he noticed his textbook is not there, what is the probability that it is at the subway? The last line is the most important. I always like to reframe it. So it's the probability that it is at the subway, given that it is not in school. This is very important. Okay, and then we can apply the conditional probability formula. So the probability that it's at the subway and not in school, school prime, divided by probability of school prime. So this formula is also in your formula sheet. Okay. So the numerator, the probability it is in a subway and not in school, that will be 35%. Okay. Divided by the probability that it is not in school. So that leaves me 2 options, either in the subway or somewhere else. So that will be 60. Okay. Simplifying that, the answer is 7/12. So the answer is B. Okay, so I'll move on to the last example, also from our EdXP database. Using a Venn diagram for 2 marks, find probability of A prime intersect B, given that we have PA, we have PB, and we have A and B to be mutually exclusive events. Okay, so I will just follow the instructions, use a Venn diagram. And since they are mutually exclusive, they do not overlap. Very important, huh? There is no overlap here, which means that they are separate, distinct like this. Okay, so we have A here, we have B here. PA is 0.65. Okay, let's label that in. PB is 0.3. Okay, probability must add up to 1, which means that the outside of the circles must be 0.05. That will add up to 1. What do we want? We want to find probability of A prime intersect B. Okay, so where does not A and B overlap? Only at B. So the answer is 0.3. So the answer is A. So that comes to the end of this video. Feel free to go to our website edxp.com to try some of our IB questions on probability. See you again soon.